All right, today we're going to go ahead and talk about factoring trinomials. More exactly, we're going to be factoring trinomials. Factoring trinomials in the form of ax squared plus bx plus c. We're not going to solve them yet, but notice we have an a value here. It's not going to just be 1. So this unfortunately causes all kinds of complications. So I'll show you how to do these. All right, so factor ax squared plus bx plus c. So before, what we did is we had made our chart, and it was whatever multiplied to 10 that adds up to be 27. Well, that's not what we're going to be doing anymore. We're going to have to do some multiplying to get the multiply value. So we're going to do 5 and 10. First and last get multiplied, and they have to add up to the middle. So A is 5, B is 27, that's the middle term, and C, the last term, the constant, is 10. So I'm going to multiply 5 and 10 and look for 50. So we're going to look for factors of 50 that add up to be 27. So we're still going to do our chart there. So factors of 50, and now we're looking for the ones that add up to be 27. But notice what we did differently. We took that first number and multiplied it by the last. Technically, we did that last time. It just this was always 1. 1 times whatever number's in the back here is just always just the number in the back. So here, it's 5 times 10, or 50. So we start with 1 and 50. That's 51. That's not 27. 2 and 25, well, there's your 27. We can stop. Now, unfortunately, we have to do more than just find the factors. We can't just write this as x plus 2 and x plus 25. That will be incorrect. What we actually have to do is we have to go back to what we called grouping. And if you remember, grouping has to deal with 4 terms. And so we're going to have to take these 3 terms and make them 4. Well, how are we going to do that? We're going to use these 2, which are really the same thing as 27. So this 27 here is going to be split up. We're going to split the b. So 5x squared stays put, the 10 stays put. But this middle, we're going to split up into 2 terms so that we get 4. So what do we get? We're going to put the 2x and the 25x. So see them in the red and the green here. So now that's 4 terms. And now we can do what's called grouping. And remember, what we do with grouping is we do the first 2 with the last 2. So the first 2 here, this is a 5 and an x and an x. This is just a 2 and an x. Well, what's in common? An x, and that comes out. And we're left with 5x plus 2. 25 is a 5 and a 5 and an x. And this is a 2 and a 5. If you need to write it all out, that's fine. If not, you're just kind of looking, what's the biggest number that can divide this? Well, 5 is. And what do we get? 5x plus 2. Now remember, the way that we write this is the first, we have 2 sets of parentheses, what's inside of parentheses and what's outside. So one is the 5x plus 2 that's inside, because again, those are the same. And then what's left outside, x and plus 5. And that's how we have to go ahead and solve these. Obviously much more difficult than what we just got done doing. It starts off the same way, but then we have to turn it into a grouping problem. And we have to obviously show our work and show the rest of it. All right, so let's try another one. Here we have the 24 and 3, so we're going to multiply those together. 24 and 3 gives us the 72, and we're looking for them to add up to be negative 22. So multiples of 72. Now again, because that's a negative with a positive out here, we need double negatives. So we're going to try negative 1 and negative 72. No. Negative 2 and 36. Nope. 3 and 24. 27, getting close. 4 and 18. That's the correct one. Now again, we don't write it as 4 and 18. We go ahead and split the b. And we're going to go ahead and take this value and we're going to make it a grouping. So it's 24, and then we're going to put 4 and 18. So 4 and 18 goes in there. So let's take a look at this first group. What divides both of these 2? We're going to do first 2 and last 2. What divides both of these? Well, 4 divides both of them, and they both have an x. So I'm going to take out a 4x. Well, that's left. When I divide 24 by 4, I get 6. Take an x out, it's just x. 4 divided by 4 is just 1. Now over here, what goes into both of these? 3. But remember, if I just take a 3 out, it's going to be opposite. It's going to be negative 6 plus 1. So I have to take a negative 3. We talked about that back when we did some groupings. It is sometimes we got to take out a negative here to make it match. This is a minus here. that's a plus, so we needed to go ahead and get to match, so we take out a -3. Well, -18 divided by -3 is +6. 3 divided by -3 is -1. Notice those match. So now we can write our answer, that's 6x minus 1, and then our 4x minus 3. All right, here's another one. Before we even get started on this one, notice something, however. If you're looking, 4, 24, and 32 can all be divided by the same number. They can be divided by 2, but they can also be divided by 4. Well, if they can, before we even get started, why not do it? So let's pull a 4 out. So now I get x squared plus 6x plus 8. And look at what I have left. I have that trinomial that I'm still going to have to factor, but there's no longer a value in front here. And if there's no value in front, it's a real easy one to write my answer for. So I'm looking for two numbers that multiply to 8 that add up to be 6. So I'm still going to do my little table here. 1 and 8 is not correct. 2 and 4 is. But the great thing is I don't have to do the grouping because there's no number in front of here anymore. It's outside. And so I can go ahead and write the 4 on the outside and then those two factors, x plus 2 and x plus 4. So this whole thing right here is what's considered the answer. So if you can factor something out of all of them, it's got to be from all three, you can go ahead and do that. All right, what about another one? 3 and 35 is 105, and we have to add up to be 26. So 1 and 105, 2 doesn't go, 3 and 35, 4 doesn't go, 5 and 20. All right, there it is. So now I write the original one, and then I split it. 5x and 21. Just with those numbers there. It's now a grouping, so I'm going to do the first two here. Only thing I can take out is x. 3 and 5 don't divide. So it's x out in front, so 3x plus 5. What about 21 and 35? Well, I can divide by 7. You can always kind of look to see what, from the first one, what needs to be there. It needs to be a 3x. Well, 3 times what is 21? So we're taking a 7 out. And 35 divided by 7 is 5. So we have x plus 7 and 3x plus 5. Which is, of course, is the C value. I don't know why it didn't pop up. Didn't like me. All right, moving on. 10x minus 23 plus 12, so I have to do 120. 10 times 12 is 120, and negative 23. Yeah, some of these numbers get really big. That's why we list them all out. Negative 1 works. 2 gives me 62. 3, 4, and notice I keep going. 5, 6, 7 doesn't work, but 8 does. Well, once I got one that works, then I'm done. So again, splitting this, take what goes into 10 and 8? Well, 2 does. They both have an x, so pull the x out. 10 divided by 2 is 5. 8 divided by 2 is 4. Negative, right? And again, we have to take out a negative because this is opposite. This is a minus plus. This was a plus minus. So I have to go ahead and take a negative. 3 goes into both of them. So 5 and negative 4. 5x minus 4 goes here, 2x minus 3 goes there, and that's our answer. Doing another one here. Notice the 2, the 14, and the 20 can all be divided. They can all be divided by 2, so I take a 2 out, and I get x squared plus 7x plus 10. Now this is just a normal one. Multiply to 10 and add up to be 7. Well, that's 2 and 5, so x plus 2, x plus 5. We got an answer right down here. There is a possibility that we have something that's called prime. And what happens there is our values, we do all of our factors and none of them work. So 3 times 5 is 15. So we're looking for factors of negative 15 that add to be 7. Well, 1 and 15, negative, 1 and negative 15. Again, when we have the minus there at the end, we got to do both of these. 3 and 5, negative 3 and 5, and 3 and negative 5. And if you look at those, none of those add up to be that 7. 4 doesn't go in, and then we already have our 5. So we've got all our factors. So what can we do here? Since there are none that work, what we say is this is a prime polynomial. It is prime because none of the multiplication factors add up to be the middle term, the b value. That is possible. So 3 and 3 is 9, and we're looking for it to add up to negative 5. Negative, Negative 1 and negative 9 is negative 10. Negative 3 and negative 3 is negative 6. That's a mistake. So this one's got to be prime. Now, even though sometimes we want to call it prime, we do need to go through all of our factors. So 2 and 36 is 72. So I start with 1, then 2, then 3, and this one's looking prime. 4, 5, 6. I got to the last one before I found the one that worked. Okay, negative 8 and negative 9 worked and gave me negative 17. You have to be ready for that. So 2x squared minus 8x minus 9x plus 36, because I split the b here with that negative 8 and negative 9. 2 divides both of these, so it's 2x, and we get 4 left. 9 divides both of these, and x minus 4. So x minus 4 and 2x minus 9. So this one does work. It is not prime. Notice I changed it from x to c. That happens a lot. If you do that, that's fine. If you want to put it back at c, that's obviously fine too. And that's what I have for you today.